In this video, I'm going to go over problems 14 to 18 on permutations. So try to follow along in your book, it'll make more sense. On number 14, it says Jasper has saved enough money to open a savings account at the credit union. When he goes in to open the accounts manager tells him he needs to select a 4-digit PIN. She also says he cannot repeat a digit, but he can use any of the digits 0 through 9 in his 4-digit PIN. How many pins are possible? So we can think back to our decision chart. He has the first digit, second digit, third digit, and the fourth digit. Since he can choose between 0 and 9, he has 10 options here for his first digit. He can't repeat it, so after he picks one, now he has 9 options, he picks another one, he has 8 options, he picks another one, he has 7 options. So 10 times 9 times 8 times 7 is 5,040. Then it says for part B, notice that this is starting to look like 10 factorial. So remember 10 factorial would be 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1. So this right here is the first part of it. And then this 6, 5, 4, 3, 2, 1 is what's missing on this top line. And 6 times 5 times 4 times 3 times 2 times 1 is 6 factorial. So that's what's missing from 10 times 9 times 8 times 7. So another way we can write this is 10 factorial divided by 6 factorial. Because remember that would be 10, I'm going to write it all out again. So if we divide by 6 factorial, we can see that all of these cross out. We're left with 10 times 9 times 8 times 7. Alright, so it says, discuss how you could use factorials to represent each of the following situations. 4 of the 5 involve a permutation, which is an arrangement that doesn't allow repetition, and 1 does not. Write down your answers as factorials and as whole numbers. So on part A, 52 contestants submit an entry into a contest to choose a new school logo design. In how many different ways can the judges pick the best logo, first runner, second runner-up, and third runner-up? So there's the best, then there's the first runner-up, then there's the second runner-up, then there's the third runner-up. So we're really making 4 decisions here while the judges are. The first runner-up is really second place. So it's a bit confusing on the wording. So they have 52 options. If you're best, so then there's 51, 50, and 49. So you can see here that this is the beginning of 52 factorial. But we're missing 48, 47, 46, 45 all the way down. So this is divided by 48 factorial because 48 and down are missing. So with your calculators, you can type it in like this or like this, just as long as you understand what's going on. It's a big number, 6,497,400. Part B. The volleyball team is sponsoring a mixed doubles sand court volleyball tournament, and 16 pairs have signed up for the chance to win one of 7 trophies. In how many different ways can the teams finish in the top 7 slots? So the top 7 slots, there's first place, second, third, fourth, 5th, 6th, and 7th place. So again, it said there were 16 teams. So there could be 16 teams could get first. Then that leaves 15, 14, 13, 12, 11, 10. So again, this is the beginning of 16 factorial. But we don't have 9, 8, 7, 6, 5, 4, 3, 2, 1. So it's divided by 9 factorial. This is an even bigger number here. 57,657,600. Here for C, it says Carmen is getting a new locker at school, and the first thing she must do is decide on a new locker combination. The 3-number locker combination can be picked from the numbers 0 through 35. How many different locker combinations could she create if none of the numbers can be repeated? So she's making 3 decisions here. 0 through 35, so she has 36 choices, then 35, then 34. So again, that's the beginning of 36 factorial, but we're missing 33 factorial, which gives us 42,840. D is similar, except it says how many different locker combinations can Carmen choose from if 0 cannot be used for the first digit and none of the numbers can be repeated. Okay, so from 0 to 35, but she can't pick 0 here, so it's 1 through 35. So she has 35 options. She picks a number, but now we're allowed to use 0. So she has 35 options again, because we're taking away whatever number she chose, but we're adding 0. Now we're taking away whatever number she chose, so we have 34 options left. If you wanted to write this one with factorials, that first 35 would just have to be in front, and then times 35 factorial over 33 factorial. This 35 would be this one, and then we can see it's starting to count down. Either way, we get 41,650. And finally, part E, how many 3-digit locker combinations can Carmen choose from if she can use any of the numbers 0 through 35 and she can repeat numbers? So for her first option, she has 36 choices. Second choice, she has 36 options and 36 again. So this is 36 to the third. Again, she's allowed to repeat. So this is 46,656. This is not a permutation because you're allowed to repeat. So not a permutation because repetition is allowed. Okay. So for problem 16, it says a permutation is an arrangement of items in which the order matters and items cannot be selected more than once. So a permutation is no repeating and order matters. What we mean by that is, it matters if you get first place, second place, or third place. So that's a permutation. So on part A, it says that write is a list of all the license plate letter triples that can be made using the letters A, B, C. How is this list different from the arrangements child can make on a line on the refrigerator with the magnetic letters ABC? So if you look at the list of license plates, it could be AAA, AAB. They're allowed to repeat. But if you think about a child with magnets on a fridge, they have ABC. They can just rearrange these. So this list here is shorter because we can't repeat. So this would be a permutation because we're not repeating, and order matters. It matters how they line these up. The list in the book, that is not a permutation because they're repeating. Part B, it says, imagine a group of 8 candidates. 1 will become president, 1 vice president, and 1 secretary of the school senate. Now imagine a different group of 8 applicants, 3 of whom will be selected to be on the spirit committee. How will the list of 3 possible people selected from the 8 differ? Which list would be longer? Which is a permutation. So you have 8 people to choose from for secretary, or president, vice president, and secretary. So we have the president, VP, and secretary. So this would be 8 times 7 times 6. 8 people to choose from. The other one, if you just want a group of 3, it's a little bit different. We'll get into how it's different later. Is a shorter list. So here, if we made a list of all the ways, there would be 336. This is going to be a shorter list because here you don't care if you get picked first, second, or third. You just care if you're on this committee. You guys would be all equal. You're just in this group of 3. Here, you have rankings. This is a shorter list because order doesn't matter. Here, order matters. It matters if you're president or not. So again, this is a permutation, not a permutation for the group of 3. So kind of skipping ahead, I want to put this by a permutation because it's important. The formula for permutation, this is part of 17, but we'll write it twice, is NPR. That's kind of how it's written. And there's a spot for that in your calculator. So on the graphing calculators, if you hit math and go over to probability, you can see it number 2. NPR, and it's going to pop up like this, where you type in a number, then you go over and type in your other number. NPR is n factorial over n minus r factorial, where n and r are going to be n objects and then arranged r at a time. So N is how many things you have, and R is how many decisions you're making. Might be another way to write it. I'm kind of running out of space. I'll write it on the next page for 17. So NPR, again, that's N factorial over N minus R factorial, where N and R. So R is the number of decisions being made. So think if you're picking a 4-digit PIN, this would be 4. It's the number of decisions being made, and N is the number of choices. And this is, again, for a permutation where order matters and you can't repeat. So write this down, get it in your notes. This will be on your final quiz. The difference between a permutation and what we'll go over next week is a combination. So to kind of apply this, 7PR, what this means is 7 factorial over 7 minus 4 factorial. Notice it's, let it focus there. Notice that the denominator's in parentheses. So this is really 7 factorial over 3 factorial. Some of you are just going to go straight to here because you're going to say 7 minus 4 is 3. You're not going to write this step, and that's okay. And remember what this means is 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. So this is really 7 times 6 times 5 times 4. So if I plug this into my calculator, remember, I do math, probability, NPR, so that's 7 and then a 4, and we get 840. And notice if I plug it in this way, 7 times 6 times 5, times 5 times 4, it's 840, because that's all that this was calculating for us. 52P4 is 52 factorial over 52 minus 4 factorial, which makes our denominator just 48 factorial. Remember, this is 52 counting all the way down to 1. This is 48 all the way down to 1. So this is really 52 times 51 times 50 times 49. So again, if we do this on our calculator, math, probability, 52P4, it's 6,497,400. All right. And then problem 18, it says, how many distinct ways can the letters in the word MASH be arranged? I'm going to show this 2 different ways. So think the letters in the word MASH. If we just want to rearrange them, we'd have 4 decisions here. And we also have 4 options. How many letters could be first? Well, 4. Then we use 1, we have 3 left. Then we use 1, we have 2 left. We use 1, we have 1 left. So there would be 24. And we could write all of those out if we wanted to. I'm not going to do that. So this is for the word MASH. There's 24 arrangements if we wanted to kind of mix these around. But part B is for the word SASH. So it's a little bit different here. So I'm actually going to list all of them, and it's going to be a little annoying. S-A-H-S, S-H-A-S, S-H-S-A, S-S-H-A, S-S-A-H. Alright, so that's all the ways, I believe, if we start with an S. Then if we start with an H, H-A-S-S, H-S-A-S, H-S-S-A, and then I could start with an A, S-S-H, A-S-H-S, A-H-S-S. So here, there's 12 arrangements. We'll go over why in just a minute. So this is obviously less, it's half as many. Part C wants to know how many ways can we arrange the letters in the word SAS. So there's SAS, there's SSAS, SSSA, or ASSS. So there's only 4 ways. So again, even less here. Why? That's the difference. That's kind of what we're trying to figure out here. The reason this has only 12 options, so here for MASH there were 24, and we really got it because it was 4 factorial. 4 times 3 times 2 times 1. Well here, this is like 4 factorial, but it's divided by 2 factorial. So that's where 12 comes from. This one is 4 factorial divided by 3 factorial. The reason here we're dividing by 2 factorial is because there's 2 S's. I don't know which one was the first S and which one was the second S. There's no differentiation. Here we have 3 S's, so we divide by 3 factorial. So when you're trying to kind of make a list and to account for repeated letters, you divide by that factorial.